In this video, we're going to have a quick look at electrolytic cells. An electrolytic cell is one in which electrical energy is converted into chemical energy. As with a galvanic cell, in an electrolytic cell, we have an anode and a cathode forming our electrodes. And again, it's oxidation that always occurs at the anode and reduction that always occurs at the cathode. And the electrons travel through the external wire from the anode to the cathode. Now, in our electrolytic cell, we have actually got an external source of power or electricity, which drives the movement of those electrons. In the electrolyte, the positive ions are going to be attracted to the cathode, while the negative ions are going to be attracted to the anode. So pretty much everything we've seen so far is the same as for a galvanic cell. The most obvious difference when we're just doing the basic labeling of these diagrams comes down to the charge of the electrodes. So in a electrolytic cell, the anode is the positive electrode and the cathode is the negative electrode. In an electrolytic cell, both of our electrodes are contained within the electrolyte, the same electrolyte, and the oxidation and reduction occurs when that electrolyte comes into contact with the electrode. And those electrodes can be active or inert. Now, something that's important to take note with the electrolyte of an electrolytic cell or electrolytic cell is that it can be aqueous or molten. And whether you're using an aqueous or molten electrolyte depends on the substances requiring oxidation and reduction. Because in the electrolyte here, if it's an aqueous solution, you have got the substances dissolved in the electrolyte as well as the water molecules in contact with the electrodes. And whichever one is easier to oxidize or reduce will be oxidized or reduced. So if water is going to be oxidized or reduced in preference to the species in question, you'll need to use a molten electrolyte. Ions such as copper, silver, nickel, zinc, and lead will be reduced in preference to water. That means that they can be reduced using an aqueous electrolyte. When water is reduced, hydroxide ions and hydrogen gas form. This will occur if the electrolyte contains highly reactive metals because it's easier to reduce the water. So aluminium or anything above it in the reactivity series will require a molten electrolyte for it to be reduced. Ions such as chloride, bromide and iodide will all be oxidized in preference to water, which means that they can be oxidized using an aqueous electrolyte. If water is oxidized at the anode, oxygen gas and hydrogen ions are formed. So just to recap, an electrolytic cell is one in which electrical energy is converted into chemical energy to cause a non-spontaneous reaction to occur. The oxidation and reduction reactions occur in the electrolyte where the ions of the electrolyte come into contact with the electrodes. And what is oxidized or reduced depends on its difficulty in being oxidized or reduced, which is related to its reactivity. With our reactive metals, water is reduced in preference to the reactive metals. So a molten electrolyte is required to reduce reactive metals such as aluminium or anything above on the reactivity series.